Hi, in this video we're going to do some more work on equations involving complex numbers and complex solutions. As we've said in previous videos, when we have a complex number as a solution to an equation, we expect to see a conjugate pair of solutions, provided that the coefficients of the equation are real numbers. So let's take a look at this problem here. They want you to solve this equation. Z cubed plus 2z squared minus 3z minus 10 equals 0. I'm expected to get three solutions. Because the coefficients are all real numbers, I'm expecting to get a pair of solutions that are complex and one solution that would be real. So in other words, I'm expecting to get three brackets. And those three brackets will no doubt have a z at the front of each of them, because I've got to make up this z cubed. At the end over here, I know that I've got three factors that must make up this number over here at the end, minus 10. These two I'm going to put in a bracket because that's going to be my conjugate pair. That conjugate pair will have a constant term at the end of it that must be a factor of 10. So in other words, in this first bracket, I could either have something like 2 times 5, or I could have 1 times 10. And this is going to take you back to work that we did on the remainder theorem earlier this year. So we're going to try out with different solutions. If z was equal to 1, what do we get? We get 1 plus 2 minus 3 minus 10. And that's not equal to 0, so therefore not a root. If I go and put in minus 1, I'm going to get minus 1 plus 2 minus 3 minus 10. That's also not going to equal 10, so it's also not going to be a root. If I have z is equal to 2, what do I get? I get 8 plus 8 minus 6 minus 10. Hey presto, we've got something that's equal to 0. So therefore I know that z minus 2 is a factor. It doesn't look like the word factor. Is a factor of the equation. So in other words, z cubed plus 2z squared minus 3z minus 10 must equal z minus 2 times by something. We know the first term has to be z squared in order to make my z cubed. The last term has to be plus 5, because minus 2 times plus 5 is going to give me my minus 10. At the moment, I'm sitting with minus 2z squared, and I'm allowed plus 2z squared. So in other words, this product over here must make plus 4z squared, in which case this element here must be plus 4z. Okay, this is work that we would have done earlier this year with the remainder theorem and the factor theorem. So this should be a bit of a recap for you. In other words, what do I have? I've got z minus 2 as a solution, and I've got z squared plus 4z plus 5 as my other factor. And I think you can see by looking at it, we can't factorize that thing. So my solutions are that z minus 2 must equal 0, or that z squared plus 4z plus 5 must equal 0. This we know is that z can equal 2, and we've seen that already. We were expecting that. This one over here, I'm going to have to use the general quadratic formula. Z is going to equal minus 4 plus or minus the square root of 16 minus 4 times 5. And it's going to be all over 2. And so z is going to be minus 4 plus or minus the square root of minus 4 all over 2. So in other words, this is going to be minus 4 plus or minus 2i over 2. And so my solutions are z is going to equal 2, or z is going to equal minus 2 plus I, or z is going to equal minus 2 minus I. And there are my 3 solutions for that equation. Have a look at this example. The equation of the equation 2z cubed minus z squared plus 4z plus k equals 0, where k is real, has a root of z is equal to 1 plus 2i. Find the other complex root, and hence find the value of k and the real root. So I know that if I have a root of 1 plus 2i, I must have another root of 1 minus 2i. And again, if I take these back, I'm going to get z minus 1 plus 2i. This should look familiar to you. We did some examples like this earlier. And remember, there was this trick that we used where we just rearranged the order of this, so made this z minus 1 minus 2i times z minus 1 plus 2i equals 0. And so we're left with z minus 1 all squared plus 4 equals 0. And so I've got z squared minus 2z plus 5 equals 0. And that is a factor of this equation over here, 2z cubed minus z squared plus 4z plus k equals 0. So we've got 2 of the factors, the 2 complex factors. If we want to find out what the real factor is, we need to know what that value of k is. And in order to do that, we need to have a value that will satisfy the equation. And they've told us that. They've told us that z is equal to 1 plus 2i is a root of the equation. So I know that I can substitute z is equal to 1 plus 2i into this thing. So I need to put it into here. So I'm going to have 2 times 1 plus 2i cubed minus 1 plus 2i squared plus 4 times 1 plus 2i plus k equals 0. Now I've got to do a bit of calculation over here in order to get these bits here. I could use the binomial theorem, I suppose, but I'm just going to do it longhand. I know that 1 plus 2i all squared is going to be 2i squared is going to be 4 2i all squared is going to be 4i squared, so it's going to be minus 4. And then I've got plus 4i. So in other words, it's going to be minus 3 plus 4i. 1 plus 2i cubed is simply going to be 1 plus 2i times minus 3 plus 4i. If I multiply that out, I'm going to get minus 3 8i squared, so it's going to be minus 8. And here I've got minus 6i, there I've got plus 4i, so it's going to be minus 2i. So in other words, it's going to be minus 11 minus 2i. Right, so all I have to do now is to go and put those things into their relevant places. What have we got? We've got 2 times minus 11 minus 2i minus 3 plus 4i plus 4 plus 8i is going to equal minus k. And now it's a case of tidying up my real and my imaginary parts over here. What have I got? I've got minus 22 plus 3 plus 4. So that's going to give me 15. And I've got minus 4i minus another 4i is going to give me minus 8i is equal to minus k. Something doesn't look quite right here. I don't think I should be getting this thing here. Let's just recheck this line. I'm doing too much in my head here. Minus 22 minus 4i plus 3 minus 4i plus 4. That's not a k. It's supposed to be an I. Plus 4 plus 8i is going to equal minus k. And what have I got now? Minus 22 plus 3 plus 4 is going to give me minus 15. Minus 4 is minus 8 plus 8 is going to give me 0. Yes, this is looking more like it. Yep, there we've got it. K is going to equal 15. In which case, we know that the equation looks like this. 2z cubed minus z squared plus 4z plus 15 is going to equal, and we had our original factor, z squared minus 2z plus 5. First element's got to be 2z, and the last element has to be plus 3. And so the real root is going to be at z is equal to minus 3 over 2. Hope this makes sense to you. Goodbye.